Hello! Today I'm going to be showing you how to create a game using assets that were exported from Brickadia. So first we need to find the save we want to use. So I'm just going to look for World War I planes in BRS gallery. This is a great save made by Rotary. I mean, look at that. You got all these planes to pick from. Download that. And I'm going to put that into my builds folder, and I made this little BRS gallery folder. I'm going to save that there. Now that's downloaded, and I can go into the game. Start game. And for this save, I make sure I'm using the color palette. Yeah, this is Rofary's color palette, and this will just let me use the exact colors that he used in that build. Load it up. Press gallery, World War I fighters. Cool. So the plane I'm going to be putting into Unreal Engine is this Fokker D.VII. It is a great World War I era plane. Very nice colors on it. So let's just pick this out. Select only it. Then Control X, cut, clear all these bricks. And then I'm going to kill myself, and that just puts me closer to the center of the map. And then I can Control V and paste it right here. Cool. So now I'm going to open up the console by pressing the tilde key. I'm going to type in bricks.export model. I'm just going to name it Fokker D.VII. And by default, this will just export only the exterior showing faces. But if you want the interior faces of the mesh to export as well, I think it's just you got a 0 at the end, and then that will export it without with all the extra faces inside of the mesh. So export. Okay, and so if we check in our Brickadia folder, saved, exported models, and there it is. So now I'm going to take it over to Blender. I'm going to delete everything that's in here by default. Go to File, Import GLB. And I'm going to go to my exported models folder and pick that up. Default settings should be fine. And let's see. So here's our model. If we change the shading to this, we can now actually see all the colors and textures. So great, that looks great. And also I want to move it so that it's kind of centered. I'm going to right click, set origin, geometry to origin. Actually I should merge everything first so that it brings everything all at once. I'm going to click all these. I'm going to right click, join. And this will create an object that contains everything. I'm just going to name this to Fokker D.VII mesh. And this will be Fokker D.VII. Okay, so now I can do the set origin, geometry to origin, and that will bring it down there. I also want to change the location of this so that the propeller is in line with this axis, and so that the origin is closer to the center of gravity for the plane. And to get a reference for that, I'm just going to look up Fokker D.VII center of gravity, and we might find a good image. So yeah, you can see that it should be a little bit in front of the rear end of the wheels. So I'm going to move and drag this about here and then up so that the axis goes through the middle of the propeller there. Make sure this is pretty close to spot on. There you go. That will just make it easier in Unreal to, when we add the forward velocity, we'll add it such that it's adding the forces in line with like where we would expect the thrust to come from, because the thrust comes from the propeller. And we want to get rid of this transform. We want to still be 0, so we're going to click it again and set origin to 3D cursor, and now this is all zeroed out. This is the new center of our model. Okay, so we hop into edit mode real quick. Tab. And there's a lot of triangles we can look at. One way to simplify that is go to mesh, or no, face, and then tries to quads, and that will just make it a little easier on the eyes. And we can also clean up this mesh a little bit. We can go to mesh, clean up, merge by distance, and this will just remove all the vertices that are on top of each other for whatever reason. And as you can see, that removed 8,560 vertices, so that'll make the model a little easier to work with. One thing we can also see if we go into the wireframe mode and look at the faces, you'll see that even though we exported it without the internal faces, there are still some leftover internal faces. For example, these little triangles in here. And these can be annoying when trying to create the vertex groups for the rudder control, elevator control. So I'm going to select these. I apologize if I'm incredibly slow at doing this. I don't claim to be a Blender expert by any means. Then delete those faces. And there's another one sneaking over here. Delete. Pick one. This side too. Just get this nice and pretty. Cool. So that's the elevator, and then the rudder is already clean. It doesn't look like there's any crazy mesh nonsense going on in the rudder. We can look at the ailerons, and we do have a couple triangles in here. Bye. Okay, so there's those triangles gone. And now I want to address ahead of time some issues we're going to have when rigging this model. So we want the rudder and the elevator to be able to rotate independently of each other. But as you can see, there's this edge where the rudder and the elevator meet. And when that's going to be a problem because we want to be able to move these guys around separately, but right now they move all together. So one way we can solve that here is going to be a little annoying to do, but we just go into edge select mode. We try to make sure we're selecting this edge. Make sure we're selecting this. Oh, I guess this is already separate. Well, never mind then. I was going to say we would have to split these edges, but it seems like these already are split. So I'm just going to look at the transform for this. And I'm going to change the Y just by a little bit. And that's going to make it easier to select between these two differently. Negative 0.191. Negative 0.195. And same for this edge up here. Aha! So I think this edge up here is still connected up on this vertex. And just gonna double check that. And vertex select mode. Yeah, it's constrained. I did a split, mesh split, faces and edges by vertices. And hopefully I can select just one at a time now. Not sure that's what we wanted. Let's undo that. And this time I'm just going to do what I've done before and select the edge and do mesh split faces by edges. And now I'm going to, yeah, there we go. This is what we were looking for. This behavior where we can actually independently move these edges. Oh, beautiful, beautiful. So make it easier, I'm gonna try to select both of these at the same time. Okay, there we go. I'll move it, yeah, just right there. Okay, let's see if we can repeat that on the other side. So select this edge, mesh, split, faces by edges, and now can we, oh god, I have to run that again. Mesh, split, faces by edges. Oh no. This is why I love Blender. It's not Blender's fault. It's 3D modeling's hard. It's really still connected. No, it shouldn't be connected. Okay. So that was just a problem where even though they weren't connected, I was unable to select the edge individually. But saw I can, I guess, temporarily move this face out of the way. And that should give me access to select these edges without interruption. Oh, you know what? That's not going to work because even though it took this face out, this edge is still lining up with this part of the rudder. Okay, okay. So I'm going to do, bring that back. Again, mesh plus faces by edges. Maybe if I take this and move this out of the way. Okay. There we go. And then I'll try to move this face back to where it should be. I'll copy the Y from this and put it into here. And then I want these vertices to all be in line with each other. There's probably a way better way of doing this, but I do not know it. Y, apply it to these. And then fix these vertices as well. Okay. That's probably the hardest part of all of this, is just messing around with the model in Blender right here and getting these vertices to not be overlapped with each other. But now that we figured that out, now we have to tackle our potential problem with the ailerons, because we look closely around this area. If we pull away these faces, we'll see that we are missing some faces here, and that's going to look bad when we rotate our ailerons and we just have a hole in the mesh. So we're going to fill in this hole. We can select the four corners and say F. That'll fill it in. Color looks a little wonky, but that's okay. It's at least it's filled. Nice. And then the same thing here. And once again, I'm just going to move this part ever slightly away from the rest of everything else, so that there's no overlap issues. And I'm going to copy the coordinates again. Just apply it to these edges. Good. Should just apply it to the C individually. Pretty tedious, but it will be worth it. The same thing for the other side. Have the face, pull it away. Forgot to mention, I'm using Blender version 3.0, so make sure you're updated to that if you want everything to look exactly how it looks for me. Should have pulled it out a bit more. It's going to be hard to select. Okay, got those faces. And I'm going to do some fix movement. So this is something that when they add the vehicle feature in the game, we don't have to mess around with all of this to see what flying around would be like. I'm really excited for that. I know it's still a bit of a ways off, but I think that will make a huge difference in the gameplay. Nice. So there's both sides. All right, now we can start worrying about our vertex groups. So if we go to this green triangle thing here, let's give us our object data properties. We'll see these vertex groups. And this is where we're going to differentiate the different areas of our model that we want to be controlled by the bones. And this will allow us to individually move these control surfaces, which will be really nice for making an animated moving plane type thing. So I'm going to make a group, and I'm going to make this the rudder group. So I need an elevator group, a propeller group, prop, right aileron, up aileron, and that should be good. I'm not going to bother with the wheels, that's just too much effort for someone like me. Okay, so I'm going to start with the rudder. We're going to go into this weight paint mode. I'm going to bring down the radius a little bit, make sure the weight's at 1.00. For the fall off, I'm going to set this to the constant fall off, and that will make it so that every vertex is either 100% part of the group or isn't, and that's what we want. We don't want anything in between. So I'm just going to paint these vertices and get everything filled in. So yeah, so that's actually the first time now. Yeah, guy was fancy and before. You want to be using the this video fancy swing. Yeah, there. Yeah. Oh shoot. Yeah. Yeah. I love it. Right. Oh shoot. I need something to do. Cool. Sometimes. Again. What the heck? I see something. This has to be a joke. Oh god. So you're trying to do 0%. So these guys. Yeah. Yes. Alright, so we're painting these groups. Nice. Alright, so we got all the vertex groups. So now we can start thinking about the bones. I'm going to go back to object mode, and I'm going to add a armature. I'm going to call this the Fokker arm. And we got this bone. For the first bone, I'm going to call this just the root bone. I'm going to hide the mesh so we can look at it. Nice. This is a root bone. Go into edit mode, and I'm going to add some more bones. This will be our prop bone for the propeller. And the propeller is gonna be facing like this. That's a 0. No. And I'll put this where it actually is. And that'll probably be fine. And I'll duplicate this bone. Click duplicate and bring it up. Use this for the ailerons. So what really matters here is that this ball at the, it's called the head of the bone, is where we want the aileron to rotate around. So, and this guy can be facing this way so that when we rotate it, it rotates the way we want it to. I don't know how better to describe that. So I'm just gonna mess around with this until this looks like it's in the right location. I'm using this square at the front as like kind of a reference to where it is vertically. And I think that's pretty good. So I'm going to duplicate this bone. I'm not gonna, I want it to be exactly the same spot so I can just drag it across. Yeah, like that. Then this will be the left aileron. One thing that we can do to look at these better is go to the there's a way to make these bones show in front of the actual model. You know what? We're not going to worry about that because I don't remember how to do that. And it's not important. Okay. So delete this. And we'll bring this guy to the back for the elevator. And it doesn't matter where this is, this way at all. So I'm just going to put it here. And for the rudder as well. No, this out so it's easy to see. Cool. So there's all our bones, and now all we have to do is rename these to be where they actually are. So this is the right aileron. So whatever name is in these bones will kind of correlate it to the vertex groups that we made earlier. Later. Make sure these are named exactly the same. And now we can actually assign this armature to the mesh. So what we do is select the object on the armature. Parent armature I do with empty groups. And now if we go into pose mode and we select one of these bones, we can rotate it. And there we go. There's our rudder rotation. We also have our rotation for our elevator. Beautiful. And for the prop, that's a fun one because it's going to go round and around. And now we can put these bones in a way that Unreal Engine is going to like. So we're going to select all these bones and go into edit mode first. So start rotor shift root parent make keep offset. Those are on order. We want the root to be the root. So root shift parent make keep offset. Okay, now the root is the root in the hierarchy. It's the parent of these children bones. And these are the bones actually doing all the magic. Okay. I think we are now ready to export. So I'm going to do file. I also want to save our work. I don't want to lose this. Fokker. See if I go to file, export, FBX, Fokker D.VII.FBX. I'm going to scale this up because I know last time I imported it, the scale was all wrong. It was like really small for some reason, so I'm going to export it by 100. I'm not going to do apply transform because this can break the bones. For smoothing, we're going to do face, armature, and this all stays the same, and we get rid of add leaf bones. And we don't have animation, so I'm not going to bake animation. And hopefully this configuration will be okay. Export. And now we can actually start going into Unreal Engine. So for this, I'm using the Unreal Engine 5 preview. It's not like we're actually taking advantage of nanite or lumen or any of those features here. I don't think so. But it's just the latest and greatest, so why not? It keeps connecting to my Steam VR, but I really don't want it to be doing that. No, I don't want to set up Steam VR. And let's make a new project. Maybe make a new one. Games, blank. Gonna be a blueprint project. Desktop, maximum. We don't need SAR content. I'm gonna call it BrickFlight demo. Yes. All right. Now we can actually start importing. So we'll do file, import into level, and browse to that folder. So it's in Brickadia, saved, export models, Fokker D.VII.FBX. It's going to put it into content. For this, the only important thing I believe is that instead of computing normals, we're going to import normals. But otherwise, all the default settings should be good. Yeah. Let's see if we get any warnings. Texture name clash. I don't think it's a big deal. Importing skeletal mesh that don't have a mesh node with no scale is not supported. That doesn't make any sense. That's like not English. Importing skeletal mesh that don't have a mesh node with no scale is not supported. What the? Yeah, let's just ignore that. What's important is, can we actually see the object? You know what? I'm not seeing anything. That's not good. Is it because of these materials? Let's see. So one way to quickly check is to go to material, and instead of the base color, I'm just gonna plug in the vertex color. Save that. And where the heck is this? Where did our mesh go? All right, maybe we messed up by exporting it with scale. Let's try exporting it again with some different settings. export scale 1. That might have messed it up. And rid of all this. Let's try that again. Make sure that's import normals. Not importing animations. Please work. Hey, yeah, that's what we're supposed to see. Okay, so I guess that scale probably wasn't good to have. Okay, but yeah, you see here that it says 100 on all the scale. I wonder if we can bake in a scale. Okay. So now we have this. Okay, so the first thing you're going to say is we have the textures, but where did all the colors go? And to make this a bit easier as well, I'm going to just import the original GLB file, and that will make some materials that we can start out with that will be nice to use. So I'm going to first edit the plugins list and search for GLTF, and we're going to enable the Datasmith GLTF importer. Restart, save everything first. We need to save the level, Fokker level. And now if we go to content, Datasmith, then we can go back to find our exported models folder, Fokker DVI.glb. I'm going to make that a new folder for GLB import. Just call it materials textures. And we're only going to import the materials and textures. And then under this master, we're going to edit this to take advantage of our vertex colors. So for the glass material, I'm going to get rid of the base color. Let's say vertex color. We can just drag the opacity directly to the opacity. There's going to be some color space issues between linear RGB and sRGB. That's kind of a whole subject on its own, but basically we're just going to add these nodes sRGB to linear and do a bit of color conversion to our RGB values before plugging them in as the base color. Make float free. Connect all these up to base color. And now we should have glass. Yeah. Okay. And you can see why I wanted to import it directly from the GLB. It gives us like our default roughness and metallic values, and it does some stuff with the texture mapping that makes it look proper. I'm gonna do that for the plastic bevel as well. So get rid of that base color, give the vertex color. Once again, do the sRGB to linear. Make flip free. This is another one of those things where I'm sure there's probably a better way to be doing this, but this is just the way that I figured out, so this is how we're doing it. And then for this one, this one's a little fancy, so for the base color again, and vertex color, RGB. Just copy and pasting that. Flip free. Plug that into its original. Sweet. So now if we go back to content and we go to our skeletal mesh. No, not our skeletal mesh. If we go to our cross, go to Fokker D.VII. Okay, so yeah, go to this asset details, and for all these, we want to replace it with the material that we imported. So I'm going to get rid of these materials. Force delete. We're going to go back to this, and in all these empty material slots, we're going to fill in what was there before. So DMC plastic material. I know this is the glass material. So DMC glass, plastic bevel 5. There we go. Plastic inlet border, and make sure to use the material instance and not the material. Metallic bevel 5. Plastic stud 5. Plastic inlet center 5. And now we look around. We have all the textures that colors we wanted. There's the glass. Beautiful. Save that. Cool. Now I'm going to create, I'm just going to put all these textures in. We don't need these original textures anymore, I don't think. Yeah, they're in here. So we can get rid of these textures. We don't need the FBX scene import anymore. Now we just have the actual mesh. So I'm going to make a new folder for meshes. I'm going to drag the skeleton and the mesh in there. Is he yelling at us now? This is still okay. So I'm going to go in here, and I want to create a collision for this plane. So what I'm going to do is make a static mesh out of the skeletal mesh. So up here I just say make static mesh, put it in meshes, and I'm going to say Fokker D.VII static mesh. Okay, so now we have a static mesh, and for this we want to give it collision. And for its collision, I'm going to make it a complex collision mesh. That's just itself, so that has all the fine-grained collision. And it's going to be use complex collision as simple. What is this? I'm not sure if we need to make that. Anyways, but since this is going to be on top of our skeletal mesh, we need to make it invisible. So we're going to add another material for invisibility. So I'm going to create a new material, call it invisible. And I'm just going to make it a translucent surface. I'm going to promote the opacity to a parameter, and that's just going to stay 0. So this is just going to render nothing. So we go back to our static mesh. We can set all of the materials to visible. So this way we're going to have the collision, but it's just not going to look like anything. Actually, for now, I'm going to keep just the plastic part visible, and that way I can see if it's scaled appropriately relative to the skeleton mesh. You'll see what I mean by that. So we go back to our main blueprint class for this Fokker. We're going to rename it Fokker BP. We'll call it Fokker Pawn. And we're going to make this a pawn type class. And to do that, where it says parent class actor, we want to change the parent class to pawn. How do we do that again? There's a button somewhere to do that. I don't want to open the source file. Man, I really wish I knew. Edit class settings? Oh, here we go. Parent class on. Cool. And I'm going to delete everything already in here. I'm going to add a static mesh. And this is going to be the parent for everything. So we'll call it Fokker. And we'll make it the seam root. And this is going to have the static mesh, the collision mesh, and we're going to have to give it the scale of 100. I'll lock that. Okay, so now we have that in place. We are going to simulate physics for this. We're not going to use the default gravity. And collision physics actor, that looks good. And then we can start adding the skeletal as a posable mesh. And this posable mesh will just have the skeletal mesh that we imported. And this is where I wanted to check that our scales were in line with each other. So you can see that this is way too small as well. So that's because it made this 0.01 for some reason. All right, make that 1. It's back where it is. And now that we know that they're on top of each other, we can make this invisible again. And cool, now we can only see the skeletal mesh. Now we need some cameras to look at the plane with. So we're going to make a spring arm for the camera. And we're going to put that around here. And we're going to add a camera to that. Whoa, big camera. That's 0.01. And we'll move the okay, yeah, we want our camera to be at the end of the spring arm. And make our spring arm length more like 500 probably. And then when we put this back here and we give it an angle, say 20 degrees, negative 20 degrees actually. And then point this 20 degrees so that's facing forward. Now we'll be looking at the plane from like this type of view. We're actually flying it. So now we can start working on, well, before we do anything else, let's see if we can actually just load it in game. What we're going to do is settings, world settings. For the game mode, we're going to make a new game mode. And we'll call this flight mode. And for the default pawn class, we're going to choose the pawn we just made, which is the Fokker pawn. So now if you press play, we can see our plane. And this is exactly what we want. And our floor is on our way, so we'll probably put the player start up a little bit. And there we go. That's our plane. Looks like we could be a little bit zoomed out a little further, so I'll go back to the spring arm and then change this to 4500. Get some distance on there. So now, didn't see that. Okay, now let's look at actually making the blueprint for this. So I'm just going to get rid of the default stuff. What do we want to do? We want to actually be able to move the plane. So one thing we want to think about is the throttle. We're actually have to set up the inputs first. So we're going to go to project settings and input and start making the keybinds for everything. So our throttle is going to be an axis that it's not going to be an axis. It's going to be a value between 0 and 100. And we're just going to have buttons to increase and decrease our throttle. So I'll do throttle up, and that's going to be shift, up shift, and then throttle down, control, and axis. We need roll, pitch, yaw, and this will be a roll. We're going to use A and D. D. And one of these is going to be minus. This is wrong. We can fix it in the blueprint. Pitch, W and S. Then yaw is Q and E. It's really hard to search for just a single letter. And then negative. Nice. So now that we have these, we can go into our pawn. We can say, when we get the input for, let's say, throttle up, it's pressed, and throttle down. And we're going to need a variable to keep track of which of these is actually being pressed. So that we can actually calculate the modifier on the throttle. So what we're going to do is create a variable called throttle up pressed and throttle down. Drag these in. Set throttle up press. Set throttle down press. And we're just going to have it so that when it's pressed, it says it's pressed, and when it's released, it says not released. The same thing for throttle up. And there we go. And we want to adjust our throttle. Make a function. All of this I'm stealing from another tutorial. I'll put a link for that. That shows how to set up a pretty basic plane actor. It's pretty helpful, but I make a few small changes to what he does in that tutorial. So for the throttle, I'm going to say, so in this function, we can get our current value for throttle up is pressed and for throttle down is pressed. And we can use these with a branch. Say if throttle up is pressed, then we're going to increment our throttle amount. So we need a variable for that. Throttle out. Just make that here. So that's down. Then we can get our throttle value. And then we can set this value. And similarly, can say if down is pressed, decrement throttle value and set that. And go back and start talking about what we want to do on the event tick. Every tick we want to add a gravity force. So that will do force, add force, Fokker. Just we'll say negative, do acceleration change. That should be good. And one thing we can also do is we can, in our throttle, print out the throttle so that we can see what our current throttle value is. So we'll do print string that into here. Once again, this is something where there's probably a much cleaner way of doing this, but I'm just doing it the cheap and dirty way. File that and hit the game. Let's see what's happening. Pressing shift and control. Oh yeah, so we actually need to call our throttle functions from somewhere. So we're going to do that saying when on begin play, we're going to set function the timer by function name. Call the throttle function. Call it every 0.1 seconds looping. See if that's good. Okay, so now we have an actual throttle value that we can increase and decreasing. Let's see why that is. Throttle down pressed. Oh, yeah, we need to actually get the control flow into this branch. So let's put that there. And now our throttle can go up and down. Nice. And now we need to actually take our throttle into consideration. So we can do that by saying get our throttle value and get our add a linear forward velocity to our Fokker. So add physics which one should we use? Set physics linear velocity. Actually, just try adding a force. So we'll do add force. add a force in the forward direction, so get forward vector and we'll multiply a forward vector by the throttle. And we'll multiply the throttle by constant. I'm just going to put in 200 for now. I'm not sure if that's going to work. So add in this force, acceleration change. And let's expand our floor so we can actually see how we're moving relative to it. Looks like we're not moving. What would that be? It's complex. Oh, okay. So I think this is actually a problem with trying to use the static collision mesh. So what I'm going to do instead is, instead of using this complex collision mesh, I'll clear that out. I'm just going to say project default, and I'm going to use the generated auto-convex collision. I'm just going to use the defaults, press apply, see how that looks. Hopefully that's good enough. And now we'll see what happens. Okay, so now we're actually falling, and what happens when we start adding throttle? We stop moving forward. That's what we wanted. Nice. We also need to talk about lift. So we'll add a upward component of force for our lift. And actually break this out into a function, so I'll make a function for thrust. And I'll just get all of this and put that into there. So it's thrust. Make a function for lift. And we'll get the up vector of Fokker. And we will, let's just do this based on the throttle value. That's just going to be the simplest way to do it. You can play around with making it better in the future. And so we're going to multiply here by throttle value by some smaller number, let's say 20. And so now let's try add force. Oh, we just need a call our function. Another thing we're going to want to do to avoid this just accelerating indefinitely is create some sort of dampening or dragging against the current motion. So we'll make a drag function, and we'll do drag for both the movement velocity and for the rotation velocity, so like the torque. So for the angular velocity, we'll get the physics angular velocity in degrees of this, and then we'll negate it. And we will multiply some constant. So we have float. What's going on here? angular damp constant. And we'll set this to, I'm just going to try 0.5 for now. And we will set ePhysics angular velocity. Well, we have to add these two together. So this value is vector, so add vector. Is it just to add angular velocity? Yeah, add angular impulse. So I'll just try using this instead. Just playing around with this, to be honest. Not really sure this is all going to work as intended. All right, so then for our linear velocity, we'll get linear velocity and we'll negate it. And we'll multiply it with some value. Variable linear velocity constant. We give it to 1. And we will add force. Not allocation. Just add force in general. Acceleration chain. Put it all in here. Looking great. Press, lift, drag, and gravity. So these are the main forces. So let's try again and see if it will just take off. What happens? Okay, it's doing something. Let's add in our controls so we can play around with this a little bit better. So I'm going to get the x-axis, and with this we can not the axis value, we want to get the input event. We get the actual input event. Yeah, there we go. And so whenever there is a change in pitch, we're going to add a force, add a torque, and the torque is going to be on which axis? It's going to be on the, let's just try the axis. Vector. Try the forward vector. And do the forward vector. Before I do this, let's try. axis value 5e4. Really a lot of trial and error doing this stuff. Doesn't seem like anything's happening there. Yeah, I guess that would make sense if you're just adding the torque into the direction you're moving. That's not going to do anything, is it? Yeah, it wouldn't. So what we have to do, what do we have to do? Okay, so I looked it up, and for the pitch, we want actually the right vector, and we're going to do a lerp of our vector. This is v, make the alpha 0.1, and then have that as the input to our torque. We're going to multiply this right vector by our axis value. Our axis values can be multiplied by some large number that helps define how much control we actually have. Put that into there. And let's try that. Oh, that seems to be doing something. It's pretty slow. We might need to increase that, but that looks like what we want. So change that to 4,000. And we can do the same thing as this for our roll and our yaw. So this will be our input axis for roll. Once again, we need the actual input event. And the yaw. This will be the up vector. For now, they're all going to have the same amount of control, but we'll change that in a bit. Let's see how this flies. Looks like we got the roll directions mixed up. Also seems like it doesn't have any continuity. I think our angle damping is too strong. So we'll go to drag, and our angular damp constant, we're going to put that way down. We're going to say like 0.01. Hopefully that feels a bit nicer. Okay, that was a little bit too low, but as you can see, we have something. Oh my god, this is ridiculous. We have something kind of resembling a plane. Yeah, that's insane. And we'll fix the roll by just negating this. Okay, let's start to think about animating these bones as well. So I'm going to make a function for the bones, and I'm going to get the, well, for the propeller we need to get the current bone position, so we're going to get the bone rotation by name, and this will be prop, get it in component space, and we need to convert the rotator this returns to a quaternion so that we can do some non-gimbal locked rotation onto it. And this is going to be multiplied by just a constant rotator, which will have the rotation amount in here. Let's just do, we'll plug the throttle value into this, so that the throttle will control how fast the propeller spins. And then we'll multiply these two values. Should be quaternion. And we'll set bone rotation by name. Prop. And this new rotation in component space. And we'll automatically convert the quaternion back to a rotator for us. And this is something that, let's try just putting it in every tick. See, nicely that works. There we go. Our propeller spins. So it looks like the damping is too high again. The angular damping. That back down to 2. Let's see. Let's do the rest of the bones. So we actually want at the beginning to get the initial rotator for the different control surfaces, and that's just going to make it easier to make a relative movement to that. So we're going to init the elevator. We have an initial color, initial right color on, and initial left color. And these are all going to be of the type rotator. And then at the beginning, where it says event begin play, we can get the rotators of these bones. We'll get bone rotation by name. Component space, the elevator. And then we can set an elevator, this value. We're going to do this for all of these guys. So this will be for the rudder. This will be for the this will be for the left ailer. Okay, so there's looking graph all of our initial rotations. So we can set one rotation by name of the rudder by getting the current yaw. We'll multiply that, since it's a value between 0, -1, and 1, multiply that by, say, a max of 18 degrees. And we'll make a rotator like that. Let's try the and we'll add that to the, if we get the initial rudder, we can apply that rotation by multiplying this. Not that we want to make it to quaternion. And multiply these quaternions. Then that will actually be what we set the rotation to. See how that works. So we should be able to throw on axis. But instead to y. Once again wrong, put it to z. There we go. It is facing the wrong direction though. So we want this to be -18. Okay, so now we can do something similar for the elevator. For the elevator, I want to get the pitch and use the knit elevator. Set the once again, when you play around with which axis we're rotating until we get it right. And go the opposite direction. Just set 20 for this. Cool. Now we have the elevator. And actually, if we want smooth rotations, like in my last video, what we can do is modify this angle by the, and have this like linearly interpolate to this angle. And so what we do is make a value for rudder angle. This is a float. So we get curve rudder angle. And we'll interpret 2. This is our current. This is our target angle. So we get out. Our delta time is get world delta seconds. Curve speed is like to start 2. And we also want to set the current rudder angle to that new variable. So this for here. So now that should be smooth. Yeah, that's smooth. Move it a little faster. 5. Then we'll do same thing for everything else. curve elevator, curve right aileron angle, curve left aileron, float, float. This blueprint is starting to get really messy, really disorganized. I think it's fine. We know what we did. Do the same thing, of course, for the right aileron and the left aileron. So we just need to change this to roll. One of these is going to be the opposite of the other. And let's see, right aileron, left aileron, get angle, set. It's aileron angle. Set that. And make sure we have the control flow going all the way through. I think that's it. Let's see how it plays. Nice. Let's try flying this a bit. So it seems like we have way too much momentum in directions we're not actually trying to go. So we need to work on the drag for that. And we also need to switch around these values. You're going the wrong way. So for the drag, for the this, let's try 0.1. You know what? I think I actually have the. I think that's right. Never tell if I got the. Rotation correct for the. Yeah, this is still really messed up. So what I'm going to do is change this so it's not so wonky. How do we fix this? So we're getting the current velocity. We're adding a force that's negative of that velocity. We don't want to get rid of the forward velocity. We just want to get rid of with velocity not in the forward direction. So what if we subtract the forward vector from this? So let's get a vector but that's not going to be relative. So this is a math problem. I hate math. We need to get the component of this velocity that's not in the direction of the forward velocity. So I guess one way would be to project it onto a plane, and that would get rid of one of the components. So let me get the plane. The make plane function. That's not what we want. That's not the kind of plane I'm talking about. Project vector onto plane. Okay, so we get this vector and we project it onto the normal of the forward vector. And now we do that too. Okay, that seems to work a little. Oh, the heck happened? That wasn't good. We just kind of flew away there. That's not good. Now we're just infinitely accelerating into the distance. Let's do this again. Let's add another force. That's just all right. So now we're going to get the forward component of our velocity and add negative force. Oh, I see the problem. We didn't negate this vector. So we were adding velocity in directions we were already going, which is never good. But we will still accelerate forward infinitely, I believe. And so, yeah, I'm gonna negate this. Like that. And that will get rid of our forward momentum, but we want to not get rid of all of our forward momentum, just a little bit. And so this is where we will get our linear velocity constant and put it in here. Let's see what that looks like. Still feels like not rolling quite fast enough, so we might want to reduce this by a little bit more. What else does it feel like? What do we want to be different? Feels like our lift isn't doing that much. We could try to increase the influence of our lift. So let's put this up to 100. See how that works for us. That's lifting us a ton. Ooh, I think a problem with the lift right now might be that since we're getting rid of our velocity in the direction we're not going, we need to also have a multiplier for this. Make it pretty high. This multiplier will be velocity damp constant. And this will be, just try 0.9, or let's do 0.8. Put that, what we do. Let's see how we do this. Having a hard time telling if that's actually doing anything. So I mean, this is viable. This is I'd call this like a playable game at the moment. So you could obviously go a lot more in depth with this, like try to actually do an accurate physics rig for this, but this is the basics for getting to fly around. What we could also do, but I don't really feel like doing in this video, is showing just exporting the GLB of another save and then using that as a terrain to fly around. There's not much special about that is any different from what we did here. The only thing is we just drag the actor, or drag the mesh into the map and then give it that complex collision like how I showed before. There's our plane.